Okay, so on question 4 of the 2009 calculus paper, the use of maths, we've got a trig calculus question. Although it doesn't ask for a graph in any of parts of the question, it is essential that you're able to draw graphs and interpret graphs for this kind of question, which is quite common in the exam. For example, this here tells us something very specific about the curve, the 25. So does the 2, and so does the pi. Okay, so before doing the question, I think it might be worth actually just doing a quick sketch of this curve. It's a cos graph, so therefore it's starting at the top. That's the first thing to know. Okay. However, it's been shifted upwards by 25. Okay, it's been shifted upwards by 25. So, whereas 25 wasn't there, it'd be down there. It's been shifted upwards by 25. Now, as well as that, the 2 tells us the amplitude. So we know that that length there is 2. It's been shifted up 25, so that's 25. So we obviously know that it's oscillating, going between 27 and 23. Okay. The other thing to note is that this tells us something very useful called the period, which is the amount of time it takes for the graph to repeat. The period is always 2 pi, because remember in calculus we're always working in radians, not 360 degrees. 2 pi divided by pi, which is equal to 2. Okay, so it's equal to 2. That means it repeats itself every 2. So we look at this graph. That's 1 repeat, so it's going to be 2 down here. Okay, and that's another repeat. That's going to be 4. 4 there. And another repeat. It's going to fall down at 6. Halfway down from here, we go down at 6 there, for example. Okay, didn't ask for it in the question, but we need to be able to have those skills in order to actually answer some of the questions, because it's a good strategy for actually doing the question as a whole. Okay, when we actually turn to the question itself, the first part is very straightforward. It's just a case of substituting. There's only 1 mark for it. So it's just a case of substituting our values into our x. So we've got x equals 25 plus 2 cos pi times 3, which is 2 pi plus 2 pi 25 plus 2 times minus 1, which is 23. But actually, we could have seen that quite easily from our graph. 3 there reads across from 23. So it's kind of confirmed with our graph. In the exam, of course, that's all that's expected. But if we have various ways of looking at the same thing, it'll help us convince ourselves that we're actually right when we come to the end of it. Right, the next bit is just to differentiate this function here. Now, we're noting the differentiating of the function. 25 is a constant, so that actually disappears when we differentiate. If you think about it, it wouldn't make any difference to our curve if it were down here. The gradient wouldn't make any difference if we were down here, up there, or whatever. Shifting up and down doesn't affect the gradient of the curve, so the 25 disappears. Cos differentiates to minus sign, and the pi kind of goes with it because it's pi t. So we've got dx by dt is equal to minus 2 pi sine pi t. Okay. Right, so it's asked for the maximum value of dx by dt. Now this is, again, I'm going to draw a graph now of dx by dt. If I label my original graph, label my original graph as it should be, which is t along the x-axis and x along the y-axis, if you like. Might seem a bit strange, but t is time, and time is always on the horizontal axis. X is actually a distance, displacement, so that's on the vertical axis. This is our graph of dx by dt. Let's just fit it into the okay. So that's our graph of dx by dt against t. This is dx by dt. Okay, now notice that these points correspond to each other. So for example, that 0 corresponds to the gradient of 0 there corresponds to dx by dt being 0, which of course makes sense. Right, it's going downwards because it's a minus sine curve. Right, it's going downwards because it's a minus sine curve first. So that's why it's going downwards first. Okay, and it starts at the origin because it's sine, not cos. It's going downwards because it's minus sine, and at the origin because it's a sine and it isn't a cos. Okay, so that's the curve of it. But what are the numbers along here? Well, if we look at it, we can see that the period is still the same. And that is actually, in fact, always the case. The periods of a graph, of a trig graph, compared to that differentiated, is always the same. So the period is also, same calculation, equal to 2. So again, just like before, that's got a period of 2. That's got a period of 2. And that's got a period of 2 again. So this number here is 4. This number, that number there is 2. That number there is 4. And that number there is 6. You may wonder why I'm doing all this, but it actually is relevant to this question, which we're actually coming to. Again, it didn't ask for a graph, but if you're not able to picture the graph, the question becomes very difficult. So there's the graph for it. The question actually asks for the maximum value of dx by dt. Do not get fooled by the word in the question. It wants the maximum value of dx by dt, not the maximum value of x. The maximum value of x is obviously 27. You can see that. The maximum value of dx by dt is 2 pi. Okay, not minus 2 pi. All the minus 2 pi says is that it goes downwards first. Yeah, it's going downwards first. So that's the only reason why we've got the minus 2 pi. This length here, same as the amplitude, is 2 pi, and that would obviously be the same as our maximum value. So the maximum value is 2 pi. Okay, and then this is where the graph actually is second to none, because I suppose you could just remember that even if you couldn't draw a graph of a trig function to save your life, you could, I suppose, remember that that number in front of the sine or cos minus, taking away any minus sign, ignoring any minus sign, will give you your maximum value, or your amplitude in this case. Obviously, if it were a maximum value of this one, you'd add the 25 as well. In this case, it isn't. It's just that value there, 2 pi, ignoring the minus. So I suppose you could do that even without the graph, but this last part of the question where it says find two values of t, where this occurs. It wants the two values where the t is at its maximum. So the first one, if you're looking at the numbers along here, we've got 2 there, we've got 1 there, we've got 3 there, 4 there. We want the times when it's at its maximum, which are there and there, which are clearly 1.5 and 3.5. So that's the final answer to the question. So t equals 1.5 and t equals 3.5 are the two values which when the value of the dx by t is at its maximum. Okay.